Okay, good morning and welcome to this webinar on large heat pumps in district heating. My name is Eloi. I'm Director of the Market Intelligence Unit within REPower. And today I will accompany you as moderator during these discussions. So first, a bit of housekeeping. So I will share a few questions from the audience after the panel. So please use the chat to ask questions to our speakers and mention also to who you want to ask your question. So we have great speakers with us, and actually we will start now. Time is tight, and I will give the floor to Aurélie, Managing Director of EuroHeat.
Yes, thank you. Thank you very much, Eloi. Hi, everyone. Welcome indeed to this webinar on large heat pumps, winning team to REPower EU, which is also the second webinar delivered by our newly established Market Intelligence Unit. So we are very happy to have all of you here. I think it's a good time to recall, it bears repeating that the current crisis that we face is profound, is unprecedented, but is also undoubtedly a heating crisis. We know that heating and cooling represents today about 50% of the European energy demand, and a decent 40% of it today is supplied by natural gas. On the bright side of things, we know that most of this natural gas is used to provide low to medium temperature heating, so hot water and space heating for buildings, but also low to medium temperature for industry. And the good news is that most of those uses today can already be decarbonized and defossilized by existing, already available clean heating technologies. This is why in May 2022, the European Commission proposed its REPower EU package. It's a plan, a set of measures to drastically reduce natural gas dependency in our heating, in our buildings, and in our industry. In this regard, large heat pumps in combination with heating and cooling networks have been acknowledged as a critical solution to support the phase out of natural gas in buildings and in our heating sector at large. This was mostly recognized for densely populated area. And the good thing is that those benefits were confirmed and further demonstrated by IEA's recently released report on the future of heat pumps, which was back in November this year. So large heat pumps combined with heating and cooling networks from our perspective have indeed several benefits. The first one of it is really to enable the harvest of untapped renewable heat sources like geothermal or solar thermal, but also to tap into circular recovered heat sources from urban environments, such as metro or sewage water infrastructure, tertiary buildings like data centers or supermarkets, and also public buildings like hospitals. The second benefit is that they maximize the decarbonization potential of renewable electricity sources, such as wind and solar, by absorbing this electricity when needed to produce renewable heat and at the same time support the balancing of the system. And thirdly, when combined with electric boilers or with thermal storage, large heat pumps in heating and cooling networks support greatly system flexibility and security. And they enable us to provide already today daily, weekly, but even seasonal storage and flexibility, which is a big missing piece in our energy transition today. So this is why we felt it was the right moment to shed light on those benefits, but also to look at the market for large heat pumps in district heating and cooling, to look at the potential, the growth prospects, and hear about the key experts from the field, which we have today speaking with us. We have produced a report which will be released today around 2 p.m. But this webinar today will be the opportunity to share with you already some preliminary finding and mostly exchange with you on the future that lies ahead, which we are pretty convinced is quite bright. So thanks a lot, and I wish all of you a wonderful discussion today.
Thank you very much, Aurélie, for this sharp introduction. And I will jump to our second speaker, Fabian. Fabian, you have been part of the team of experts at IEA. We prepared this really important and timely report that was out 2 weeks ago on the future of heat pumps. It was mentioned by Aurélie. At EuroHeat, actually, we are very pleased that you address not only small but also large heat pumps. We need all of them. And this morning, Fabian, you will present the IEA report and you will provide info on state of play and the outlook for heat pumps. Go ahead, please.
Thank you very much, Éloi. Thank you very much, Aurélie, for the introduction. Yeah, Fabian Voswinkel from the IEA. Exactly 2 weeks, or actually less than 2 weeks, since we released the report on heat pumps. And Aurélie has already said it, that our heating is very strongly dominated still by fossil fuels. So 40% alone is natural gas. This is a worldwide number. And currently we're only standing at about 10% in heat pumps and 11% in district heating worldwide. Now, of course, there's a big differences between the different markets. So in Europe, some leading markets, Norway has 60% of heat pumps, and Sweden and Finland about 40%. That is of course a way higher number. But we see but we saw a tremendous growth in these last years. So while worldwide we have seen a growth of like 15% in sales last year in heat pumps, there were some markets in the EU in total that we are 35%, and then Poland and Italy, for example, showed over 60%, which is of course a remarkable number. Now, at first, I'm going to talk mainly about the residential heat pumps for the unit, and then go into more detail of the role of heat pumps in district heating. Now there was the growth, and what that means in the world that we saw in 2021, capacity additions of about 96 gigawatts, which is already, as I said, after there has been quite a growth in 2021. But according to our models, if we account for all the pledges that have been made by governments until now, we are expecting that this number will triple by 2030. And as we know, 2030 is not even so far away, 1/3 of which would then come from China each year, and about a quarter each from Europe and North America. And that is, of course, due to very strong policy support that we are already seeing, and that we're also expecting to become even more. So this way we would get to about 20% of heat pump usage, direct heat pump usage in the world by 2030. That's a doubling. So if we make a more spotlight on the European Union, where, of course, it's particularly urgent due to the energy security issue, that we want to get away as quickly as possible from the dependency of natural gas. In 2021, we saw about 2 million sales, and we're expecting that this will also more strongly go towards existing buildings, and will about double until 2025 and go up to 7 million in 2030. So a rapid growth path that we're seeing in the scenario that accounts for all the pledges that have been made by the governments. And in terms of supply chains, we are also seeing that industry is kind of following suit. They're investing large amounts in expansion of capacities to be able to deliver on these ambitious targets. So what does that mean for gas usage in the EU? If in this growth path, we're expecting 7 BCMs of reduction until 2025, which is roughly the amount that flows through the Trans-Adriatic pipeline from Azerbaijan offload in 2021. And in 2030, the bar gets a lot bigger here, as we see. So there are about 21 BCM can be saved, which is about 15% of all the pipeline imports from Russia in 2021. And that is only residential heat pumps. So not large heat pumps in district heating, not heat pumps in industry. So this number can be a lot larger if we would account for these, and if there's also more and strong policy support going into that direction. In terms of a change from fossil fuels to electricity, we can expect worldwide again about 80 BCM less use of natural gas, and also large amounts of less usage of coal and oil, which will be very important, of course, for the climate targets, which we should not forget that we're not only talking about energy security these days. And well, the good thing about heat pumps is while they, of course, use electricity, but due to the usage of ambient heat or other heat sources, we will need way less additional electricity than we save in fossil fuels. So we would only need less than a third of that amount of energy additional from electricity. But that is the overall number. The peaks are way more of an issue. That is why when we have to really strongly account for having flexible options, using the flexibility potential of heat pumps also. They have to be smart ready at the least, so that these potentials can be used and that the peaks can be held as low as possible. So in terms of emissions, we're expecting that until 2030, about 0.5 gigatons of CO2 can be saved worldwide by switches of space and water heating to heat pumps, which is about the amount of GHG emissions emitted by all cars in Europe at the moment. But, or not only a but, if we think about costs, now the costs vary quite a bit between different countries and markets, and they are upfront higher than for example, of a new gas boiler. Although the levelized costs, if we're looking at the 2021 prices, actually in most markets, we would already see that it would be more economical to heat with a heat pump than with a gas boiler. So we're expecting that in the household savings would range from about $300 per year in the United States to $900 in Europe. But still, we're having high upfront costs, and this is sometimes prohibiting for people to make that investment. So we have we're seeing policy support to feather that a little bit. And this is also not only in the cost, but there are barriers to that uptake. The cost, the one thing, making a decision in a multi-owner building to make such an investment is difficult, and then there's other things like it needs the space for a heat pump unit. There are concerns about the noise, about the optics of the outside unit being on the street side, for example. Then the efficiency might not always be perfect. So, and of course, the peak load there are all issues that may not make heat pumps always the best solution. So especially in dense urban areas, there's a big potential then for using district heating. There is already district heating, of course, also used, and that can utilize so many more heat sources, for example, like the wastewater. Aurélie had already mentioned many of them, different types of waste heat. And finally, I'd already mentioned the flexibility, using that as basically a big heat storage to smoothen that curve in peak load will be very important if we're seeing in parallel the strong uptakes also of the residential heat pumps. And the other good thing is we have already these networks in place. So 60 million people are already supplied by heat pumps in the by district heating in the EU, and another 80 million are in cities that have such networks, so can be more easily expanded, which is a big potential to basically switch the supply over if at the moment only 25% are coming from renewable sources and only 1% from heat pumps. That of course can change, and we're seeing that many countries in Europe already have targets in place to decarbonize their district heating networks. As in the last webinar a few weeks ago, it was talked about the Bundesförderung für effiziente Wärmenetze, the German federal funding for the heating networks, where they approved 3 billion euros to invest into that decarbonization. So there's a lot of drive in this, and we're seeing very promising examples also of what has been happening already. So in Finland, for example, there is the Katrivala heating and cooling plant as a good example. There's 5 large heat pumps supplying 105 megawatts of district heating and 60 of district cooling, and it uses such an integrated approach of warm wastewater and cool seawater to supply both of them. And finally, one heat source that is available everywhere. There's a lot of warm water flowing under everyone's feet in the streets, and that can absolutely be used and be used way more efficiently on a larger scale, like in district heating networks. So there's a very good project. We use heat, which looked at the potential. So if we're thinking only of wastewater treatment plants, there are about 4,000 of these that are in 2 kilometers distance or less to district heating networks, which have a very high heat availability. So there's big potential there, and that's not the only one. So that would be my few words, and yeah, I'm happy for questions.
Thank you very much, Fabian, and once again, congrats for the big job with the team you did on the report. You mentioned the reuse heat project. I mean, it's really a golden mine of information, I think, and it is said that actually 10% of the heat market could be supplied with these new urban excess heat sources. It's if I don't know, to all participants, if you don't know the project, please have a look. It's fascinating, I think. Fabian, I have a little question for you regarding challenges. I mean, obviously, we know there is a big potential for district energy in Europe, and you mentioned some figures. But in your work on heat pumps, have you come across specific challenges for the further deployment of large heat pumps?
Yes, unfortunately, yes, of course. I was mentioning that supply chains in both normal heat pumps, like small heat pumps and large heat pumps, of course, have to work with. Is a challenge to keep pace with a strong uptake. Now there is a lot done in this direction. In large heat pumps, I quickly mentioned the industry side that also needs large heat pumps. They need compressors, and the compressors are kind of tight on the market, and they're used in many different technologies. So that would maybe be one of the major bottlenecks of having enough supply of large enough compressors for these large heat pumps. So that's the supply chain side. Nothing that cannot be solved, but it might be something that may slow it a little bit, yeah, depending on availability and possibilities. The other thing would be, I've now talked about these waste heat sources, but of course, ground source, like geothermal large heat pumps for the district heating is one of the important possibilities. And there's a lot of, it's a highly regulated areas. So deep boreholes may be limited in regulation. So this is something that it might not be possible everywhere where we would like to do it. Yes, so that's, I think, the main thing. There may be some aspects. I've had some talks with people on the ground who said that there is some autonomy thinking in kind of going away from an own heating source for the own house and going to a district heating network, which I found interesting. That is anecdotal evidence, though.
I think on the last point, it's something we can see on some markets. Thank you, Fabian. And I think for the point you mentioned on geothermal or on bottlenecks in the industry, I think that some of our panelists, I think they will be able to provide some answers. I would like now to turn to our panelists, and we will start with Lorraine. So Lorraine, you're an experienced practitioner. You have taken part in the development of greenfield projects. Today you are a business development executive at ENGIE, and you will talk to us about a great project in Paris region, where large heat pumps and district heating are making the best use of geothermal resources. Yes, thank you.
Yes, hello everyone. I've got a bad voice after COVID period, but that's okay. So today we'll present you the case study of deep geothermal heat recovery associated with big heat pumps. So as mentioned by Eloi, a greenfield project near Paris dated from 2015. So as mentioned by Aurélie and Fabien, heat pumps could play a key role in district heating and cooling in order to enhance heat recovery, for example, from waste heat, low temperature renewable resources like geothermal, I will mention here the case, or to create synergies between heating and cooling. So in this project, the geothermal resource is at 60 degrees C. It's deep geothermal at 1,500 meters depth. That's why we needed to increase the supply temperature to deliver space heating to all buildings. So thanks to the heat pumps, on one side, the condenser side, the supply temperature is increased up to 70, 75 degrees C. So it's the orange line you can see. On the other side, it's the overwater side. The return temperature from the network, the blue line, is decreased down to 35 degrees C, which also decreases the return temperature of the geothermal source. So the heat pumps, the big heat pumps in these case studies have two added values. So first, supply heating at the right temperature. Without heat pumps, we would not have been able to supply space heating in this area, and also to increase the geothermal heat recovery. So increase the renewable capacity of recovered from the network. So all this system between buildings and renewable source is a virtuous cycle, I explain. So buildings should work on energy efficiency first. So of course you've got installations, different actions, but also you can improve the heat recovery in the secondary circuit. So you see in the building a little light orange-blue circuit, which means the lower the temperature will be, the more efficient the heat pumps will be, and the more we could recover geothermal heat. So this is the virtuous cycle. So from local optimizations to global optimization. In this project, it was a greenfield project, as mentioned. It delivers 10,000 households, 100 gigawatt hours, and the construction period lasted 2 years, which is quite quick after the decision process of the cities. So on next slide, so you can see the picture with my operation team in front of the heat pumps during the commissioning. So you can see that it's very big animals with a lot of technologies in it. It will be maybe detailed more by suppliers after. So on the right of the slides, you can see the map of the network between the two cities in the suburbs of Paris, the North Chantilly, South Arcueil, and the geothermal plant is mentioned in the middle in pink. So it's interesting to highlight that the project started from an eco-district decision. The eco-district is on the north, and the city decided to create a network while this eco district was under construction, so to put pipes underground, even before the decision process of the district geothermal district heating. And the specificity of that eco district is that this area is supplied by the return temperature from the old building just nearby. Thus, it decreases the return temperature to the geothermal plant, and so it helps to better recover again the heat locally and to have a better renewable source introduced into the district heating. So it's again a local opportunity. We put pipes and then we reuse those pipes, put pipes underground, and we have reused those pipes after 1 year after, when the global district heating was constructed. So as a conclusion, I would state that to allow such optimizations between local renewable resources with heat pumps and buildings needs, it is important to keep a nearby approach in the EU directives to allow local and global optimization at the same time. So thank you.
Thank you very much, Lauren, for this short presentation. I have one question. So one barrier in the development of district heating projects is the upfront cost of network deployment. Was there any state aid in the case of RKO? And then also, how do you ensure that the heat load is there, is available to minimize the risk for investors? So are there any lessons from France to steer markets towards quicker rollout of district heating that are of interest for the EU discussion?
Yeah, a characteristic, of course, to implement such district heating, there are capex. So usually we implement those contracts through kind of concessions contract which lasts 30 years. So it helps to amortize those capex. But we are lucky in France to have some support schemes. So those support schemes to develop district heating and cooling are the heat fund. So it's subsidies on capex. In these case studies, we obtain 23% of capex subsidies from the heat funds. There is also a reduced VAT tax, so 5% instead of 20% for the end user. They benefit from it, and also we've got systems from white certificate. And what's new since 2022, there is an opportunity to classify the efficient district heating, so district heating with more than 50% renewable and waste heat, and so which to make it compulsory to be connected, so the cities can decide that around a certain area, and we've got the opportunity to have a express connection at €1 owing to white certificate, meaning that it does not cost a building to be connected. So yes, it's capex intensive, but we've got those support schemes I've explained you, and the objective of support schemes is to remain competitive in comparison to an existing standalone solutions. So in this area, it's 120 buildings connected, customers connected, more than that in buildings. And so we replaced gas boiler or sometimes fuel boilers. We didn't change anything into the buildings. And the price was at the same level at the price from the gas boilers. At that time, 2015, the gas price was very low. Now gas price is very high, and the opportunity of such district heating is that the price is completely stable, rather stable, and not really depending on fossil fuel and electricity price. So it's really an opportunity. Your second question is how do I ensure to de-risk the heat load, meaning the cities decided the project, ENGIE was awarded to construct it, and then how are we sure that the customers will sign and will get connected to the contract and will get connected to the district heating? So first, there is an estimation of the needs. the main stakeholders are the cities of Arcueil, and they've got some public buildings, the city of Gentilly, and also the social housing. And so all those three stakeholders, they've got buildings which corresponds to 50% of the delivery of this district heating. And so first, so we asked them beforehand if it was not binding, if they were for this project, if they were in. So it was yes. And the second job was that the city, they have mandated an engineering company to estimate the loads of the potential building that could be connected to the network. So it was a big work that has been done. And on our side, when answering to the tender, we did also that work, and we added other opportunities. This good estimation work to estimate the needs and the potential bidding that could be connected to the network is really important. So it's data management. Then I mentioned stakeholder management. And the third thing is that into the contract, we mentioned there is a clause to de-risk the project, mentioning that we will start the drilling work, which is CapEx intensive, and then the rest of the plant and the district heating into the cities, we will start the construction work only after we will have signed supply contract with clients representing up to 60% of the consumptions. Yeah. So does that answer your questions, Eloi?
Thank you very much, Lorraine. Yes, it did answer to the questions. Thank you very much again. Now I would like to jump to our next speaker coming from Denmark, where district heating is well established. As you know, the Danish market, the high share of district heating and other factors are enablers to phase out fossil fuels from the heat market. Kim, you are head of development at Fjernvarme Finn, and today you will speak about how heat pumps are a great interface to transit district heating towards 100% sustainable heating. In Odense, you have developed a great project with Meta to use heat from data centers. So please go ahead, Kim.
Yes, thank you for the invitation and for the floor. I'm very happy to be here, just following these other speakers who's giving really good examples on how to the importance of heat pumps and different examples on how to use them. And I'll just give some case study, you can say, on how have we done it in Odense in Denmark. But first of all, I just think I'd like to emphasize that I appreciate that everybody do business cases comparing to fossil fuels, and this we just need to recognize that in the long run, fossil fuels is not an option. So I recognize we need to compare to gas and other things, but in the long run, stop using that. And there's not a biomass for everybody. So heat pumps will be part of the future energy system. So let me give you just a brief introduction to our company. We are the third largest district heating company in Denmark. We supply about 100,000 households and industries, greenhouse production, and we have a lot of pipe because it's a very flat area. One family houses we supply, so we need a lot of pipe. We run a fairly low temperature grid, around 60-70 degrees when we approach the households. That also means that we can collect surplus heat from the different installations around town, because we can collect it at around these 60-70 degrees. And of course, even though you can say district heating is kind of a monopoly, we also need still to be competitive to keep and to attract our customers. So we are very much focused on a low price. We are in the middle of a green transition where we are phasing out the consumption of coal we have, and here heat pumps are very important. And then we have a vision to be carbon neutral in 2030 and also support the target of our municipality. Okay. see if I can skip here. Yes. So just this is probably basic for most people, but in case it is not for some, I just wanted to state what do I mean when talking about large heat pumps. And in my world, this is heat pumps in the megawatt size, and what we have mostly worked with here at Fjernvarme Fyn is heat pumps around 4 or 5 megawatts per pump, you can say, and often when we do large installations, we have groups of heat pumps. So some of our installations are 20 megawatts, and then of course they consist of more heat pumps. We are primarily working with the ammonia compressors today, but in the future, I believe we'll also be working with carbon or CO2 centrifugal compressors. And just to compare, you can see the size of a household heat pump as well. And of course, with the heat pumps, as had been mentioned, we can collect a lot of residual heat and energy sources around, which the individual heat pumps cannot do. So this is basically our system where we are very much focused on being very flexible. So we have many plants, and of course that hasn't come overnight. We have been in operation for 90 years, so we have just kept adding and adding, and of course we're also shutting something down. But if you look on the left-hand side of the illustration here, you see some of our existing thermal plants where we actually today have coal on this unit B7, but we are now replacing it, or we expect to replace it for peak with natural gas, but we can only do that because we have put in a lot of heat pumps and electric boilers and also some biomass. So actually we are pushing out the fossil fuels, but for a few years still we expect something is needed for peak. On all these plants, actually, we have heat pumps. I think I have another illustration just to show that where I put the red star here, you can see we have actually added large-scale heat pumps. So on all the thermal units, we have heat pumps collecting energy from the flue gas or from the cooling water, or wherever there is a heat source, we collect it and push it into the district heating system. Then on the more decentral area, we have these two large heat stations. One is with Facebook or Meta, just outside them, where we have 45 megawatts of heat pumps installed and can collect surplus heat from their data center. This is completely owned and run by us, and actually the picture here behind me is one of those large heat pumps. And we also have another installation where we collect heat from sewage treatment, and that's about 20 megawatt of heat pumps. So altogether we have about 100 megawatts. And of course, these energy sources are not something that can be collected by individual households. So this is of course a very where you can see where district heating is key to introduce this to the system. Yeah, I think maybe I should just mention as well that in the future, as we see it, we will be working with power to X as well, and we will be seeing surplus heat from these installations as well, from the electrolyzers and from the strippers and absorbers. So I think we will see heat from these units as well. And that will be the next, and that is actually the next, you can say, generation that we are looking into now as an energy source. So just one other interesting thing about renewable, about heat pumps, is that when we have heat pumps and electric boilers in our grid, we are actually flexible in nearly all market situations. So when we have a high share of renewable energy in the grid, we usually have low power prices. And then we run with the heat pumps and electric boilers. And we can put some heat on storage, or we can put it directly for the customers. So there they get advantage of the low power prices when the heat pumps, when the wind is blowing. But in the other cases, in the other situations, we have low renewable energy in the grid. And then we're really happy to have combined heat and power plants because then they can provide the production. and then in more moderate situations, we can go with both, and they have synergies in between. As I mentioned, the combined heat and power plants, they also have surplus heat we can collect, and also they can deliver electricity kind of behind the meter, you can say, to run the heat pumps. So in other situations, we are able to run with both things. Also important to mention here is our heat storage. Today we can store up to 70,000 cubic meters of hot water. We are planning to build a pit thermal storage, which is 10 times as big. And that doesn't give us an opportunity to store from summer to winter, but maybe just from 1 week or 1 day to another. And that gives us the opportunity to always be flexible in the market. And here on this slide, you can see more or less how our fuel mix is. Unfortunately, on the slide, I haven't shown how heat pumps are also integrated in the municipal waste, in the straw and in the wood chips, because on all these sources, we also have heat pumps. So the heat pump shown here is heat from Meta and heat from the sewage treatment. And just to mention, the heat from Meta supplies us with enough heat to heat 11,000 households, and the sewage treatment plant supplies us with heat for 5,000 households. So that's big figures. And this final slide just is an example of our cooperation with Meta, showing that Meta has invested in renewable energy, invested in wind turbines, which are providing, of course, not directly, but on a certificate market, providing power for their data center and also providing power for our heat pumps. So then it's, you can say, completely green power that our plants are running on. And when we then collect the heat and supply it to the city, you can say we use it again. So I think that is the way forward for installations like this, and it can be you can say copied to other data centers or to a lot of other industrial installations. So yeah, so thank you. That was the slides I had today.
Thank you very much, Kim. I think you explained very clearly the strategic role of heat pumps and their interaction with the broader energy system. I have a question, on the current situation of high prices for electricity in Europe. Do you think that it will slow down projects, and are there ways to mitigate this kind of risk?
Yeah, of course, heat pumps at the moment with these extremely high power prices are under pressure. But you can say, again, other fuels are also under pressure. So I think at the moment, of course, people get a bit scared, but we just also need to recognize that this is an abnormal situation. And in the long run, we expect more reasonable power prices as well. And basically, of course, if you price fossil fuels correctly, they wouldn't be cheap either. So, but in order to mitigate risk, you can do different things. Of course, you can invest in some renewable power production yourself. Have PPAs for renewable power, so you know what your price is. So that's a way to minimize that risk. And of course, you can look into flexible systems, as we have, so you're always, you don't expect a heat pump maybe to run 8,000 hours a year, maybe it's 5,000 hours, or so you can run when the prices are lowest. And then finally, I would look into storage, both on the hot side and on the cold side of the heat pumps. So you are flexible in the markets and you can store the heat if you're providing that for a district heating system, or store the cold if you're providing that. So you can always shut down maybe or minimize your production in the hours that are most expensive. So there are different ways to mitigate the risk.
Thank you, Kim. I will turn now to our next speaker, Noel, who is coming from Spain. Noel is head of the innovation department at UNOSA, Group CEPI, and he will speak to us about how heat pumps in this example could support the decarbonization of the heat market thanks to mine water. And I think it's really a fascinating project. Please, Noel.
Hello, everybody. Thanks for the presentation. So, sorry. No. So my presentation will tackle the issue of heat pumps as a way to harness mine water heat. So just before starting, I'd like to give you a brief, a few words about my company. UNOSA is a coal mining company, was founded in 1967, and it's an own-state coal mining company. It was it started by the integration of several coal mining private companies in Spain, and now we have just only underground coal mine in operation and a power plant that uses the coal that we extract from that mine. And we have another part of the company that is in charge of dealing with the diversification activities, among them geothermal energy from mine water. So we have developed two facilities associated to two different mines. One of them is the group of facilities that you can see in the upper part of the slide. Is those installations linked to Barriado Colliery. And we have also installations, geothermal installations linked to another mine, El Fondón Colliery, that you can see in the bottom part of the slide. So those one associated to Barriado Colliery were developed in two phases. One of them started to be in operation in from 2014 up to 2016, and after that we developed a second phase that started in 2020. Then we went to the other mine, and these facilities are in operations, started to be in operation this year in 2022. So altogether, you can see that we provide energy to different types of clients, from hospitals, public health centers, sports centers, block of apartments, educational buildings such as university, secondary school, and so on. So I'd like to mention that the Barriado district heating was awarded by the International Energy Agency in 2019, and we participate in several European projects in which we are involved with our geothermal facilities. So here you can see a top view of the two developments associated to the different mines. On your left, you can see the distribution of the buildings to which we provide energy associated to Barriado Colliery, and on your right, you can see the distribution of the district heating linked to El Fondón Colliery. So let's move on now to the first phase of those geothermal facilities linked to Barriado Colliery. You can see here some figures in relation to the thermal energy that we supply. These are data referred to 2021. And you can see that we provide for heating around 5 gigawatts hour, and for cooling 2 gigawatts hour. You have also the information about the investment and all the customers that we have in this first phase: a hospital, research building of the University of Oviedo, and the building of the Asturian Energy Foundation. This is the simple diagram to show how it works. So these three facilities work as individual. So we pump out the water, and before discharging into the river, we pass this water through a heat exchanger, and that transfer the heat to a secondary circuit, and from there it goes to the heat pump or heat pumps that are in the client building. So after that, as I mentioned, we developed a second phase. In this case, we built a district heating, a proper district heating with a common heat exchanger, a common heat pump. So we provide energy to different clients, and you have here some data about the thermal energy that we supplied last year, as well as the investment and the subsidies received from the ERDF program from European Union. So here the operating diagram is a little bit different because it is a proper district heating, as I mentioned, with a common heat exchanger and common heat pumps. In this case, the heat pumps are connected in series and counterflow in order to increase the efficiency of the system. And we have several lines depending on the temperature of the client that is required for the client. So in the case of the district heating developed in the other town associated with Fondon Colliery, we have also the same data that I showed before in relation to the district heating, and also in relation to the thermal energy and investment and so on, and reduction of CO2 emissions. In this case, we decided to follow the same operating diagram that I mentioned before. So we have, after pumping the water from the mine before discharging into the river, we transfer this heat to the evaporator circuit, and from there to a condenser circuit. And we have, in this case, just one line of high temperature that goes to the different clients. In this case, the heat pumps are, as in Barredo district heating, are connected in series and counterflow in order to increase the efficiency of the system. So I think this is the last slide. Thank you very much for your attention.
Thank you, Noel. On my side, one question. Has this heating been well received by clients, and what were the specific problems you encountered? Also, according to what process did you pick up the first client in the project? Are there lessons learned here that can be beneficial for similar projects in Spain or on other markets?
These are several questions. I try to answer all of them. So I think in relation to how the clients received this project at the beginning, some of them were in some ways were skeptical because we are talking about a new technology that it was we didn't have examples here in this mining area of Asturias. So even when we provide renewable energy, we guarantee a saving in the energy cost, and we carry out the maintenance, replacement of components, and so on. They were skeptical, but after some time, and after once all those facilities, especially the hospital and the buildings of the University of Oviedo, were working properly for several years, I think that now we don't have problems with the clients. They trust the technology. So local people, public opinion in general, and local councils, even the government of Asturias, are very happy with this new use of the mines, although it is not as labor intensive as mining was, but it is a solution for the mines that for some and for some people of the company that can find a job in this new field. So in relation to the problems encountered and the process that we follow to pick up clients, so the main problem for us is to find clients that require high energy demand. Because it is crucial to have a profitable project in this field I'm talking about. in the field of harnessing the heat of the mine water. So it's crucial to have clients, as I said, that have a high demand, especially if they have demand not only for heating but also for cooling. It would be much better. And clients that can in some way feel the energy demand during the day and during the week. So clients that can make a consumption of energy during the morning, for instance, and then we have clients that they have this consumption during the evening. So these are crucial for us. So it is the main problem that we have in order to find these suitable clients to fill all the demand during the day and the week, and of course around the year. So in order to become clients, we negotiate with them after selecting the clients, as I said before, following these requirements. We negotiate with them a price in the energy. So normally they use a natural gas, and we link the price to the natural gas, and we offer a discount in the price of the energy, around 10% or 15%, more or less. But this is a negotiation with every client. Don't know if I answer all your questions, or there is something else that...
I think so. Thank you, Noel. Okay. Now, I will turn to our next speaker, coming from Italy, from the industry, from Turboden, which is a leading producer of heat pumps and also organic ranking cycles. Marco, you are Director, Institutional Affairs and Marketing at Turboden. You're also a board member of REPower, and this morning you will provide us the industry view. Please, Marco, go ahead.
Thank you, Eloi. Good morning, and thank you for the opportunity to share a technology provider point of view. We, as Turboden, we are a manufacturer of ORC turbines and industrial heat pumps. So we have seen a lot of figures today, but 78% is more or less the current contribution to the fossil fuel for the heating and cooling in EU27. So it means that this area, this is the area where to have to focus on to decarbonize heating and cooling. And as I said, Tim, before, is not an option. So it's the way that the path we have to work in the next time. The goal is to better exploit the bioheat, solar thermal, geothermal, and the key technology is the heat pumps, of course. Industrial heat pumps is a key player to help industry in this process and to decarbonize heating and cooling. I'd like to show you a project that Turboden is developing with a large heat pump, and it was mentioned in the EIA report. This process is a steel industry focused in the area in the north of Italy, strongly connected with a district heating network in the area. We are close to Milan. And this electric arc furnace residuate in the secondary circuits water at 75 degrees temperature. So thanks to this large heat pump, 6 megawatt thermal, we increase the heat leap up to 95 degrees and up to 120 degrees for the district heating. It's interesting because this electric arc furnace secondary circuits, 75 degrees, is very close to the example showed by Lorraine in geothermal. So there are a lot of similar situation, geothermal or waste heat from some industrial processes. This is a project fully integrated with a district heating network with high flexibility, and with we exploit a working fluid with low GWP. This project is currently in construction phase and will be we planning to do the test in the next few weeks, and we will be in commercial operation in 2023 in full commercial operation. We have seen the figures related to the large heat pump from EIA and from the others. So the key issue is large heat pump is a technology that it was competitive also in the period before energy crisis, 2016, 2020, but currently is one of the most competitive technologies available in terms of production of heat for industrial heat, for example. This is an example for Germany and Finland. The interesting thing is related to the component of this levelized cost of production for industrial heat. So the components are, of course, capital cost, operating cost, but also taxes and levies. And we can see that where there are specific policy in order to cut tax and levies related to the pump, there is no competition with other sources. We made some exercises in Turboden related to the potential, and we have not time to go deeper into details, but there is a huge potential in district heating application for the electrification of heat, but also in industrial processes, and we made this estimation up to 200 degrees industrial processes. We estimate that there are more or less 1,000 terawatt-hour in EU available as potential. But there are, of course, some barriers that the colleagues already shown. We need, in our opinion, three main things. The first one is a large pump accelerator program. So we need to reduce the upfront cost. Have you seen, for example, by the REPower EU, it is possible to cut some investment cost. But also we need to reduce the capex, and this is a challenge for industrial, for the technology provider. To reduce the capex, we need to do a lot of projects. We need to do a lot of volume because more the volume, less the specific cost. Think about, for example, what has happened in the photovoltaics in the last year. We have gone from cost of €1,000,000 megawatt to €1,000 per megawatt in photovoltaics, and it could be the same, not exactly the same, but could be a good push also for the reduction of capex in the industrial heat pumps. Also, the reduction of operating cost. We have seen the chart before from the EIA. When you operate in tax and levies, for example, on the electricity tariff reform, we have the possibility to reduce the operational cost. The second pillar is related to the energy efficiency. Energy efficiency is the first fuel, is the mantra of Tibirol from the EIA. And it is, of course, we have to increase the energy efficiency in order to reduce the primary energy in any case. But also we have the possibility to give more emphasis to waste heat recovery and renewable heat. Because have you seen, large heat pump is more efficient when we have less delta T, less delta T in terms of temperature. So it means that if the starting point is geothermal or waste heat recovery, for example, at 70 degrees, and you have to increase the heat leap to 90 or 100, is lower this delta T than, for example, starting from ambient air. So in our opinion, we have to be more focused on waste heat recovery and renewable heat. We have discussed with Lorraine, for example, from how to limit the financial risk with the risking scheme in geothermal is quite the same also for the industry, considering that the industry, the available heat from the waste heat from industry is not continuous, and it is subject, for example, to economical cycle or the production. So the availability of financial risk, I mean, the risking in industry is also helpful for example, energy performance contracts from the utilities and so on. Last but not least, I'm here as a manufacturer. So in my opinion, we have to strongly push an industrial policy in order to support the strong role of manufacture in EU for domestic countries and also for foreign. To do this, we need the financial support to manufacturers, a strong effort in innovation, R&D, and also training. So that's more or less all from my side. Let me say that large heat pump exploitation must take into account the positive impact of EU producer. Because if EU increase its dependency on foreign import of technology, the results of decarbonization and so on will be achieved only partially, in my opinion. Thank you.
Yeah, thank you, Marco. Actually, it was a point addressed in the IEA report that says that concerted actions by governments in partnership with the heat pump industry will be needed to achieve higher rates of deployment. And earlier, Fabian mentioned some bottlenecks, but can you develop a bit more on this? So why is it so important to support the role of manufacturing in the EU?
The role of manufacturing is important for three main aspects. First of all, jobs creation and the possibility to employ people, new employment, or to change from different areas. The second is the social benefit. That you clearly understand why there are social benefits in pushing industrial policy. And the third aspect is related to the environmental benefit. Environmental benefit that could be for domestic, for Europe, because if you apply technology, develop technology and you apply in Europe, there are environmental benefits, but also for foreign. Please consider the example of Turboden. We are currently operating in 50 countries around the world. So it means that our export quota is in the range of more than 95% outside Italy. So it means that our products are designed, studied, developed, realized, and sold outside Italy for the 95% of our product. And so is an opportunity for developing or emerging countries, and is an opportunity for the GDP at European level. So this is why, in my opinion, the industrial policy will be crucial also for support our development. Thank you.
Thank you, Marco, and thank you for your presentation. Now, I will ask you some questions from our participants, and there are loads of them. I will start with first question on cooling. This is first for Fabian, but I think that the panelists also may wish to answer. Fabian, have you considered cooling in your report?
Yes, of course. So in this report, we were focusing specifically on heating, actually, but this is one of the challenges when we talk about heat pumps in modeling because of the two possible outcomes. But in general models, when we talk about heating and cooling demands, for example, in the WEO models, also in our energy efficiency market report that we regularly bring out, we do look at both together, and also now or from now on, heat pumps have always played a big role and are playing a bigger role now in our work. We are going to present in both cooling and heating, but in this particular report, we are focused on heating specifically only.
Thank you. Lorraine, Kim, would you like also to provide some views on this question? No, I'll go for the next questions. Actually, this is one for you, Lorraine. What is the efficiency level of the projects you presented? And then could you provide some figures regarding annual production?
Yeah, thank you for this question. So the annual production is 100 gigawatt hour. So most of the time we are above 80% of renewable energy. So meaning geothermal plus heat pump. And the efficiency, the coefficient, you speak about the coefficient of performance. So for the heat pumps, it can go very high. It can go up to 7, 9, depending on the return temperature. But after you have to add also the electricity for to deliver on the network. So it depends what you take into account in your coefficient of performance. And we've got also a pump, underground pump to recover the geothermal source. As mentioned by Marco, when you decrease the delta T on the heat pumps, the highest performance could be reached, and that's all the topic to optimize the process. And when the entrance, the delta T is lower, it's better. So with renewable source and waste heat, it's easier to have high coefficient of performance, and it's the opportunities of district heating, because you can agglomerate all the needs and then to put big animals to supply globally the productions. And so with this holistic view, everybody can have savings due to that.
Thank you, Lauren. I have two questions for Kim. First one is, what was the biggest challenge when you started the project to incorporate waste heat from the data center? Can you tell us? Oh, no, I'm afraid I can see that Kim has left. So I have another question, which is really, really interesting. It's about the compared efficiency of small and large heat pumps. This may be one for you, Lauren, and please also, Marco, feel free to join. Please go ahead.
It's not an easy question. I don't know if Marco wants to answer. I don't know if it's a question of big and small. What I mentioned is for the geothermal district heating, but it could be the same with waste heat district heating. As you agglomerate all the consumptions, you have to deliver, you agglomerate all the needs, you have the opportunity to have a stable demand, because you globally, maybe some customers do not consume at the same time, but with such amount of customer, you've got a base load for the heat pumps, and that's what is important. It's the entrance temperature, the lower delta T, and also a stable load, and if possible at 100% of the heat pumps, so that I will not enter into technical details, maybe more Marco, but of course you've got a curve for efficiency, and the objective is to be in operation at the maximum of these curves to have the best efficiency. And you've got this, it's easier to have these opportunities when working globally with, of course, with large heat pumps for district heating. And when you are at individual levels with air source heat pumps, it's more complicated because you've got very low temperature outside, and the demand is only the demand of a building, so no aggregation. So just can make that comparison. But each project is different, so difficult to give a global picture.
Yes, I agree with Lorraine. What I can add is that we are designing, for example, the compressor in order to be flexible, in order to be strongly connected with the industrial processes, because in case of geothermal, the available heat is constant. In case of industrial processes, there are also some variability. So it is important to design the compressor and all the system in order to maximize the efficiency and the flexibility. Thank you.
Thank you very much, Marco. I have a question for you, Noel, and I will simply read it. Are there any requirements to recharge the mine water, i.e. by returning heat into the mine during the cooling season?
No, we discharge.
I'm not finished with the question. Just jumped because there was another one. If not, is there any limit on how much heat can be withdrawn or for how long the heat will be available?
Sorry, Eloy, I didn't hear. I didn't hear you. I didn't hear the question. So could you repeat, please?
Of course, no problem. Are there any requirements to recharge the mine water, i.e. by returning heat into the mine during the cooling season? If not, is there any limit on how much heat can be withdrawn or for how long the heat will be available?
Yes. Okay. So we have a particular case in relation to what you are asking me, because we are it is mandatory for us to keep a safety level in regarding to the water level of the mine. So we are it is compulsory for us to pump out the water just to keep this safety level. So because of that, harnessing the heat of the mine water is just a secondary, let's say, a secondary activity in relation to the mine. So because of it is mandatory for us to pump out the water, we take advantage of this fact to harness some of the heat before discharging into the river. So there are two things I have to take into account. We don't pump out the water when we want or when the clients need, but when it is necessary because of the mine requirement. So so in this sense, we pump the water, we take out the water from the mine when it is needed, and we harness this heat at the same time. So we are not re-injecting. We could study, and in fact, we are just thinking about this possibility in some places. We're thinking about re-injecting, and what is the effect of the in the aquifer, let's say, the aquifer of the mine. But it's a little bit complicated to see the effect. So now we don't, we just pump the water and take out the heat, or we dissipate the heat into this mine water when it is needed for cooling reasons. Don't know if I...
Thank you, Noel. I think it was clear, and I can see there is an interesting question. It's to you, Noel, and to Lorraine. What are the refrigerants that you are using in your projects?
It's HFO. We use normally the latest refrigerant and depending to the EU regulation.
Yes, in our case, we use different heat pumps and different just types of heat pumps depending on the installation. And in the district heating that we developed, the new district heating, we selected the heat pump and the refrigerant that could give us the possibility of raising the temperature up to 70 something or 80 degrees. That is the temperature that the clients require.
Thank you very much, Noel. And I'm afraid it's time to wrap up now. So I would like to thank our speakers, I'd like to thank Aurélie. I'd like to thank Fabien from the IEA, our panelists, Lorraine, Kim, Noel, Marco. I think you will make the case for large heat pumps and why they will be instrumental to decarbonize district heating and to transform the heat market by building strong synergies between heat and electricity and opening up the potential of new heat sources. Of course, we need proper policies to develop urban infrastructure, so heat planning, active involvement of cities and communities, and ways to get investors in the game. Marco made clear that industry is ready, but also needs policy push. So the Green Deal needs also European industrial policy. I would also like to thank our participants. Thank you for your trust. I could see we were both at some point 250 participants in the room. It's very good. If you have any questions and fancy catch up, well, just call us or come here to our office to share a coffee. And for your information, when I mentioned it, we will release, so today at around 2 o'clock, a report on large heat pumps with a market overview and a 2030 outlook. So please check your mailbox and our website. So thanks again. Have a great day and see you soon. Thank you.